So, hi, my name is Charles, and I work at a company called Automatic that many of you may know as WordPress. So, this is also just kind of putting it out there that there's one functional programmer on our mobile team. He's very lonely, so we are hiring. So, I'd encourage you to give a look. So, I basically been doing some playing around with how to get Racket to do deep learning or doing deep learning in Racket. And if there's any takeaway, I've just posted a link to a nascent GitHub repo that has my tinkering in it. But as the intro slide stated, I'm a data scientist at Automatic. What I do is mainly work in Python around pressing the words, just understanding what people are posting on their blogs and all that kind of stuff. And it's mostly in Python and another J language. And it gets very tiring, and I started off my professional life working in AI and doing programming in Lisp. So I was very curious to see whether Racket could be used to kind of plumb the depths of deep learning. So I'll kind of give you an overview of the just hopefully 2 minutes on what deep learning is. I'm sure many of you are already quite familiar with it. And go back and just talk about what I think are some of the potentials of Racket for deep learning, and talk about what progress that I've done with this kind of toy project, and just to throw ideas out there to see if there are any more reasonable and productive directions that I could take this. That being the next steps. So first, go over what neural networks are, what is deep learning, and then kind of how does deep learning work. So this is kind of a canonical description of a neural network. The basic idea is to kind of loosely build computation on the model of how the brain learns or how the brain works to establish really functions that take you from an input to a desired output, and that input could be text, and the output could be a translation of that text to another language. The input could be photographs, and the output could be some classification or labeling of that photograph. And so what does deep learning mean for neural networks? It's basically larger, faster, stronger, if you will. So the slide that I put up there is from NVIDIA, and it basically says that there's, the difference in neural networks and deep learning really is scale, that you're going from 1 or 2 layers to tens of layers. You're going from hundreds or thousands of parameters to billions of parameters. And as many of you know, NVIDIA is kind of front and central in the promotion and promulgation of deep learning because, probably within the last decade, people discovered that you could do a lot of the core computations that kind of underlie neural networks, matrix multiplies, matrix inversions, decompositions using graphics chips. And so how does deep learning work? Well, basically, or how do neural networks work, really? The idea is kind of embedded in the notion of backpropagation. The idea is that you have this network and that you have inputs to it, and you want to map those inputs to some desired output. And there's some trick that you have of mapping whatever the input is to a vector or a set of numbers. And these nodes in the network basically perform some kind of computation, a multiply, a matrix multiplication. And you posit that the output that you're getting from this network should match something. It could be a score, it could be a classification label. And you determine what the difference in that label or that output is from your desired, gives you some kind of loss or error. And the kind of insight behind backpropagation is to kind of take that loss and adjust each of the settings or parameters in this network so that the loss is minimized, kind of moving back through the network. So you could think of it as really doing a gradient search or gradient descent in trying to adjust the weights of these networks, or how the strength of one node, how the output of one node is influencing the computation that another node is performing. So I wanted to go into a couple of observations that have popped up over the last couple of years about how this kind of computation could be approached from a functional perspective, and then look at how you could specify networks functionally, and some of the kind of toy examples that I have running now. So one very popular kind of network architecture is called the recurrent network. And recurrent because you're basically running the same network over a set of time steps. Perform one computation, pass it on kind of recurrently, recursively to a copy of the network, and then you get kind of an ability to perform this computation on a sequence of inputs, like text, a sentence, or a sequence of images. And you could basically formulate the computation that's going on in this network as, again, in terms of linear algebra, that my intermediate state that I'm capturing between each of these copies of the network, H, is the product of this internal weight matrix W on the previous internal state, H of t minus 1. And then the output is a similar equation with a nonlinearity, in this case tan H, slapped in front of it. And that's basically the kind of core computations that are performed in, when we talk about layers of neural networks for deep learning. So a recent paper came out, a recent blog post and a paper about, well, we're trying to, the deep learning work over the last 10 years, or the last maybe 2 years in particular, has been a set of what seemed like to me experiments on, well, what if I tried this architecture? Or what if we tried jiggling with this portion of a network? Or what if we tried transferring the things that one network has learned to a completely different kind of task? So in this post by Cola and a subsequent paper by Balduzzi, they basically said, well, you can model a lot of what's going on in current networks as really functional operations. So for example, this kind of very simple recurrent network, to use kind of a Haskell framework, is you fold left the the product of the x's over time, and then you could take the same analysis to a fully recurrent neural network using map accumulate right, which is basically is accumulating all of these matrix multiplies. And another interesting idea that's come up recently is that of kind of specifying the network dynamically and letting it kind of figure out the types, if you will, of the data to exchange between nodes. This comes up a lot in text processing, where your sentences are going to be of varying lengths, your documents may be of varying lengths, and you don't want to say ahead of time, okay, I'm going to force each sentence to be of length 5. So recently there's been work in systems, one of them is called Dynet, another is called Chainer, that allow you to say, well, I know what my network should look like, kind of lay out a computation graph, and then as you're feeding more data, as you're feeding data into it and it's going through its iterations of learning, then it will adjust its kind of internal structure to the data that it's been received, the data that it's received. So what would this mean for Racket? So in kind of my mind, I'm thinking, well, you could model this same kind of learning composition of learning structures as symbolically, if you had the right set of expressions for it. So you want to, for at the top, model the computational elements, your matrix, the inputs that you're feeding into it, and usually once you've determined your error and you've gotten your gradients for the network, what you then want to do is some kind of optimization. So you take your gradients and you're actually adjusting your weights depending upon them. So at the second level, second set of things, once I've specified what my inputs are, then I can say, well, I want to use a stochastic gradient descent optimizer to search this space. And I can define then the whole network, wrap it up with another expression. And then once I've done that, I should be able to then run it over a number of epochs, take my input data, compute the forward prediction, which gives me the network's best guess of what the labels or signals should be, then backward compute what the gradients are, and then update the weights based upon what my optimizer is telling, the direction my optimizer is telling me to go in. So the benefits I see are in, if you take it as a given that the Racket has high pedagogical value, then one usefulness of this is to, as has been said before, kind of introduce students to the new, the kind of the newest wave of machine learning. And it's also a way of, I think, kind of rapidly prototyping new functional architectures for deep learning. And hopefully it results in new paradigms to explore. So, for example, people are grappling with Whether back propagation is kind of the way to go, whether we should be looking at other approaches to optimizing a network. Um, so, and the other thing that has been kind of one of the strong enablers of deep learning, if you will, is the kind of open, the prevalent access of really powerful low-level libraries for using graphics cards. So I've been playing around with using CUDA and CUDIN, which is the neural network library that NVIDIA's released. But there's also an OpenCL, which is an open library for programming graphics cards that doesn't come with the quote-unquote vendor buy-in that's associated with the NVIDIA codes. So my progress so far is a very simple CUDA library. It's built with the foreign function interface and with just kind of put the type Racket wrapper around it. And what I can do so far is specify these recursive neural networks, and I'm still working on getting the optimizer tied into the loop. I've also got running some, just really toy cases of putting a dynamic neural network system together. And let's see if I can quickly switch over here. Yeah, so this is kind of the current code, very kind of, still kind of very kludgy ways of specifying what the components of the network look like, and then it runs a loop over its input data and adjusts based on the error. And for the curious, here's a view at the code for wrapping the NVIDIA libraries. And is it time to wrap up? It is. So without further ado, I'm just going to say thank you. And these are some interesting directions that I've thought of, and I would really appreciate any feedback on what's kind of the useful direction for looking at deep learning inside of Racket. Thank you.